Hello and welcome to today's Digital Forum discussion with me, Alex Presley, Director of Strategic Content at Lynchburg Media. I'll be hosting and moderating today's discussion with Adrian Chiam, Head of Sales for nVent Data Solutions, SEA, ANZ and Taiwan, and also Andie Yen, Business Development Director of Data Center Infrastructure Solutions at GIGABYTE. Now I'm going to hand over to each of them so you can get more of an introduction and an insight into their roles. So Adrian, we'll start with you.
Well, thank you very much. So, I think before I give an introduction of myself, I think it's good to give a high-level overview of what nVent does. So, nVent is a global leader for system protection and electrical connection. So these are big words, but what we actually do is we manufacture various electrical connections and protection products such as enclosures, such as your bus duct, your wire basket tray, all the way to smart power distribution units, as well as your liquid cooling solution, such as your coolant distribution unit. So we also serve across different industries, such as renewable, industrial automation, data centers, commercial buildings, so on and so forth. So we are in more than 30 countries across the world. We have a headcount of more than 10,000 people, and my job primarily is to manage the, sales channel and bring our solution across to our clients in Southeast Asia, Australia, New Zealand, and Taiwan for data solution businesses. And of course, this sometimes also cover the enterprise businesses such as your semicon and so on and so forth. So that's a high-level introduction.
Thank you very much. And Andie, if you want to just introduce yourself as well.
Sure. Thank you. So also before I'm introducing myself, also give a high level of the company, provide what we are doing. So GIGABYTE is a stand for the motherboard manufacturer and designer, from the motherboard to barebone to system. And from 2023 timeframe, we are starting into the data center solution. So we're putting all of the things cluster into a gigapod solution, like the cluster, and doing the advanced cooling technology. That's why we have opportunity to work with nVent for that kind of stuff. We are providing air cooling. We are providing also direct cooling and immersive cooling. So currently, I'm doing the business development project also for the data center infrastructure, for all of the infrastructure and data center solutions with the advanced cooling technologies in GIGABYTE. Thank you.
Thanks, Andie. Great introduction. Thanks both. So obviously we're here today to talk about liquid cooling, which is something that's so big in the market at the moment. So let's kick things off by asking how nVent and GIGABYTE deliver cutting-edge built-to-spec liquid cooling technology to enhance performance and energy efficiency for its customers. And we'll start with you, Andie.
So starting to work with nVent is about 2 years ago. We start to co-work as a data center solution. At that time frame, we're providing nVent's rear door cooler, rear door exchanger for customer. For that kind of cooling technology can help customer to lower the power saving, also for the energy efficiency, and also lower the ambient temperature for the data center. For example, like time, we are providing customer with NVIDIA H100 servers. With nVent's rear door cooler, we can raising up the ambient temperature to 35 degrees. For that kind of, for data center saving, especially for the power efficiency, that will be very great help. So this is how the source we are starting working with nVent. And for that kind of technology, and also continuously we are working with direct cooling with nVent. Currently we are using nVent CDU, and we are using nVent products for the direct cooling continuously in the data center for providing customer for a higher power efficiency and a lower PUE solution for customer.
Thank you. Adrian, what are your thoughts on how nVent and GIGABYTE are delivering cutting-edge built-to-spec liquid cooling technology for performance and energy efficiency?
Well, I think what Andie mentioned really sums it up. If I were to add on to what she mentioned, is that I think our collaboration goes beyond just engineering. We do a lot of tech sharing. So GIGABYTE is one of the leaders in server integration. We learn a lot from them from a server point of view, and that's where we know how we can cater our liquid cooling solution to serve their needs. So together we would provide a more customized and more tailored solution to our client. So that's number one. And second of all, this also allows us to plan out what we should do next. So what's next to support, because now we know like what is needed in the market from their point of view and our sharing. Second of all, our collaboration also goes into marketing and training each other just to get up to speed. So this constant communication that we have with regards to the market requirement and how we can work better to serve this market, I think this plays very important role. Yeah. So that's how I see our collaboration is. It's actually on all the levels from engineering to sales to marketing.
Thank you. And I think tailoring solutions to the customer is absolutely key in today's market. So it's a great point that you mentioned there. So what aspects of serviceability matter most when selecting liquid cooling technology, do you think, Adrian?
Well, it's a good question. I think this covers a lot of aspects from the product design all the way to how you implement your solution into a data center. So let's start with product first. So when we talk about serviceability, it will be good to have redundancy on our product. Let's take, for example, Andie mentioned our rear door heat exchanger. So how we design our rear door heat exchanger is that we have redundancy on power supplies, we have redundancy on fans. So instead of having large fans, we have 12 small fans. And if you take away one fan, that fan's airflow can be compensated by the rest of those fans. So that's one. And secondly, it's also about hot swappability. And not just that, but the ease of changing it on site. So if you look at how we design our product, it's fairly easy to swap out those components. You don't need any special tools. You don't actually need any tools at all. So within under 20 seconds, you can swap out those items. So when you design on a product level something that is that easy, it's easy to train either the engineers on site, or it's easy to get a third party to come in and remotely get them to change it out. And of course, when all else fails, nVent is present across the world to provide that level of serviceability to make sure that our product is up and running. Yeah.
Thank you. Some great insights there. And Andie, did you have any thoughts on this?
So for the serviceability, this is also the cooperation with nVent for the serviceability for the product itself. And from GIGABYTE side, another advantage to mention about the serviceability is we also develop for the cluster, for the cooling solution, except the modular design, we also develop our own management tool for the software-wise. And the software can connect with nVent's rear door cooler and also the CDU products. So for the customer side, customer can using web UI to check and to monitor all of the system status, to monitoring all of the sensor for this type of the management tool. So this is also one of the serviceability point for customer to benefit.
Thank you. I'm interested to get your thoughts on why liquid cooling solutions are becoming more popular as a means of addressing heightened heat generation for modern data centers, because as mentioned, it is something that we're seeing more and more use of in this market. So Adrian, would you like to kick this one off?
Okay. Maybe I'll share my perspective because I cover a wide regional coverage, and I'm sure Andie will give great insight later on a server level. But from what we see, right, it's liquid cooling is not new. It has been around for some time. We talk about supercomputing. They have been using liquid cooling for some time, but it has really taken off after the AI race. So when servers become much hotter with a higher heat load, it requires direct-to-chip to bring down those heat load in a more efficient way. So the way I see it, right, as I was traveling around the region, trying to propose our solution, trying to see who we can work with, the real, I would say, the real demand, the real request only comes after NVIDIA and AMD and chip maker launched a high density solution. And that's where we see that data center has to adopt their infrastructure to cater to this liquid cooling, be it in a form of higher power, be it in a form to take away higher heat load through air or water. So that's what I see, and I don't see this trend stopping anytime soon. But yeah, that's all in all, that's pretty much it.
Thanks, Adrian. And do you agree with that, Andie?
Yes, yes. So from the server perspective, this is also hitting for the very hot topic for the cooling, for the direct liquid cooling. Let's take the example like just GTC happened yesterday. For Jensen's keynote, Jensen launched about the GB300 and also about the B300. So let's take the example about the GB300. Each GPU will take around 1,400 watts up to 1,600 watts. So each rack, it will up to 150 kilowatts. In this type of the design, especially from the original generated the heating from the NVIDIA GPU, it already cannot be cooling down with the air cooling or even with the ambient temperature. Otherwise, customer will need to turn on the air conditioning with very low temperature up to like 5 degree or 10 degree. So at this time frame, direct liquid cooling will be a very key point to adapt with the CPU, GPU, even the memory we are seeing right now, even the power supply. For all of the generation about the components to make us an AI data center, all of the components getting heating temperature more and more in the future. For the long run, we are seeing next 3 years, 4 years, everything will get very hot. So we are seeing right now from our point of view, we are seeing right now, especially from this year, half of our customer already transferred to direct liquid cooling. And next year, 2026, it will become more. This is also the trend from the server and barebone power design point of view.
Andie, it's an interesting point. And do you think, from your perspective, that data center companies are preparing well for the rise in temperatures that we're going to expect in years to come? Are they preparing for that now, or is there something that they could be doing to prepare a little more for that?
You mean if from our point of view, if from the data center point of view, from the user point of view, right now all of the less we see the wide range about the country. So right now we are seeing data center demanding the first one from American side, second one from China, from Japan, from Korea, even from Europe. This is 5 regions. These are the 5 regions we are currently seeing grow up right now for the data center demanding. However, power and cooling are also the critical points for this one, especially in, for example, in American and in EMEA side, for the carbon footprint policy and also for the PUE policy. More and more government policy already request or they encourage data center to use the carbon footprint materials or lower down or even use the free cooling means they are using free energy for the data center. So from the perspective of the data center environment, we think all of the trends will go to efficiency cooling, like direct liquid cooling, like standard liquid cooling, immersive cooling. We are seeing more of the trend. We're going for that.
Adrian, we need to talk about AI, and it's something that you mentioned earlier with the increase in AI and how it impacts power demands and things like that. So it's something that I wanted to cover. So I wondered, what are some of the implications regarding the design of existing data centers when considering the requirements of increased data demands and AI, for example, and how should the industry adapt? Can we come to you, Adrian, on this one?
Okay. I think data center has been adopting a more higher efficiency approach for many years. It's just that in these few years, there's a sudden ramp up of kilowatt. So let's take cooling, for example. Like if you look at a data center, say 20 years ago, it is just server racks, right? Then it evolves into server racks being cooled by crack or cryo unit. After that, in order to increase efficiency, that's where you get your UL containment so that you are able to increase efficiency of that crack or cry unit without really spending a lot more. And you start to see in-row cooler, so cooling gets closer to the server. And in recent years, I think it started in 2020, late 2022 or early 2023, with the H100 servers from NVIDIA that really introduced, like, you have 10 kilowatts per server, still coolable by air. And as per what Andie mentioned, moving forward, a lot of these servers would be liquid cooled. So how data center can really change the infrastructure, the way I see it in Southeast Asia at least, is that right now the demand is growing so fast that data center are not able to catch up. So what we see now is there are more modular data center, as in it's not built in a brick and mortar building, rather it's like containers being stacked on top of each other. So that's one, because the deployment time is much faster. Second of all, I also happen to cover Malaysia, and Malaysia is a great market. Malaysia has a lot of data center, and if you look at the trend, Malaysia wasn't really a huge data center player back in 2020. So with the recent with the recent AI race, a lot of those servers are being deployed in Malaysia in a newer data center. And when a data center is new, they cater to what the server needs, so they are more liquid cooling ready. So that's what we see. So moving forward, I think a data center will be much smaller because the power density will be higher. The megawatt for each data center has to go up because the GPUs and the CPUs are taking a lot of power. And for cooling wise, you have to have enough water in this part of the world to cool down those chips. So that's what we see. But in general, I would think that the adoption for different countries is kind of not on the same pace. So Malaysia has a lot of new data center, which is why they are more liquid cooling ready. But when you look at a mature market, say Australia, Singapore, they have a lot of existing data center that might be difficult or requires more work to retrofit to future-proof it for liquid cooling. So that's where we have to take into consideration what type of solution to provide, because even in a traditional data center that uses air cooling, there is a solution in a form of liquid to air that we could use those existing infrastructure to support liquid cooling as well. So yeah.
Thank you. It's really interesting to get both of your perspectives on the regional differences and the nuances of each region. Andie, did you have any thoughts on how AI is impacting design and data demand?
Yeah. So currently, I think from 2 years ago, 3 years ago, from the AI, most of the hyperscale data center, they are chasing with the AI development. So coming more and more hyperscale data centers. And currently we are seeing a trend is more and more customer moving from AI training to AI inferencing. And also this also impact for the requirements, because currently for the data center, we are seeing the data center, the most grow up was last year. Last year, more and more hyperscale data center grow up for the AI inference, for the AI training. And right now we are seeing most of the customer transfer to using the middle range of the GPU to doing this type of the AI training and also the efficiency inference. So type of the data center also moving forward from what we are seeing this year and coming from next year. And more customer also discussing about the direct liquid cooling solution, if also impact to the AI GPU server, more and more customer talking about direct liquid cooling, also for this type of adoption. So still for this year, we are seeing, like same thing as Andrew mentioned, we are seeing when GPU going up for the higher power density, for the higher GPU heating temperature going up and power consumption going up, we are seeing data center will become more and more enterprise will become smaller AI GPUs because of the power density already occupies more of the facility. This is also the trend we are seeing right now, but currently still AI training and inferencing, we are seeing half and half percentage. They are going up this year.
Thanks, Andie. Now, this is one for you, Adrian. What factors should be considered when evaluating the total cost of ownership of nVent's products, do you think?
Well, that's a good question. I think first of all, we have manufacturing facilities across the world. So we have support centers and sales service centers across the world. So this means that we are closer to the site or closer to our clients. Second of all, I think previously when we touched on certain topics, I did mention about the redundancy as well as the hot swappability of our product. So this should be also considered into the TCO of a product, because when you are able to provide redundancy, you reduce downtime. When you are able to change out your components quick, you reduce service time. So all these features that we built into our system, as well as our, I guess, knowledge in terms of designing the pipeline for data centers in terms of our experience in this space to provide the right solution for the right application, and our partnership with GIGABYTE, so that now when Andie was talking about gigapod solution, that gigapod solution is customized to fit what you need. So with this customization, it is better tailor-made to suit. And because of that, we also have a wide range of service. We have a good deployment team. Products are designed to mitigate downtime. So all this plays into total cost of ownership. So the way we see it, from engineering to service to product design to our collaborations with various partners across the world, all this plays a very important role to reduce the total cost of ownership. Yeah.
Thank you. Great insight there. So to round off, I wondered what the future holds for the data center industry over the next 5 years, and how you think innovative liquid cooling systems will be critical to achieving its goals. So, Andie, would you like to kick us off?
Sure. For the next 5 years, we are seeing currently for the long-term map. For the next 5 years, we are seeing, first of all, the direct liquid cooling, or even we call hybrid liquid cooling, will become a very popular and more customer or the data center, especially for the traditional data center or the standard enterprise data center, will become transforming from the original air cooling to direct liquid cooling, because for most of the components getting temperature up. So this is the first trend. Second trend we are seeing for the power and cooling, especially for the power generation from the data center side. So most of the data center we're chasing for the green data center, or even for the sustainability, looking for the sustainability, looking for the automation, and trying to, like Adrian mentioned, trying to lower down the labor, and also for the manufacturing, also for the data center. So sustainability, green data center, and power saving, power efficiency. This is also the thing we are seeing in the next 5 years. And another trend will be for the next 5 years, virtualization of the software design data center will also become a trend to saving most of the power, and also getting the redundancy for the data center design. So most of these points are what we are seeing for next 5 years. Is we're getting transformation for the data center.
Thank you. Yeah, I think the conversation seems to be centering around sustainability and what the future will hold in terms of this. So, Adrian, do you agree with that, or have you got a different perspective?
Well, I think it is well said. I hold the same comment actually. If I were to add on, I would think that one thing is for sure is that data center is looking to get more efficient. Kilowatt is going to go up, so power consumption is going to go up, and cooling is required to catch up to that technology. So today you are seeing each server at 10 kilowatt, as per what Andie mentioned. GTC just happened yesterday. I think the kilowatt per chip for each GPU is at 1.4 kilowatt already. So when you look at a ramp up of power density, you begin to question is today's cooling technology able to catch up with the heat dissipation and the kilowatt of tomorrow? So I think that this 5 years, you will see a rapid shift in different types of technology coming into data centers, from direct-to-chip to immersion to different types of technology coming in with the most efficient way to cool the chip down. So it's going to be a very interesting ride. We're going to see a lot of changes. We're going to see a lot of evolution within a cooling and a power space of a data center. Yeah.
Thank you. Well, thanks both for your insights. It was great to get a better and wider understanding of, the different regional perspectives and how your customers in each of those regions are adopting your technologies, as well as the partnership between both companies, and also, what the future has in store for this industry. It's a very exciting industry, which is, as we see, every day, that it's evolving at such a rapid pace. So thank you so much. If you've got any parting thoughts, do feel free to share. But if not, we'll say goodbye and thank you.
Thank you.
Thank you very much.
Thank you.
Thank you.
Thanks so much.
Thank you.